Welcome back to Mr. Slover's Math. Today we're going to talk about slopes and we're going to compare them. So previously we saw slopes earlier in this unit. We talked about slope was rise over run and how to graph it, and now we're going to compare two different slopes to see what type of lines that we have. So we're going to warm up first with some questions. So it says state the opposite for each number. So if this is positive 4, the opposite is negative 4. If this is negative 2, the opposite is positive 2. Second part of the warm-up is to state the reciprocal. So the reciprocal just means I take my fraction and I just flip it over. So whatever is in the top is in the bottom, whatever is in the bottom is in the top. And if you want to use math terminology, whatever was in the numerator is now in the denominator. Whatever's in the denominator is now in the numerator. So if I looked at letter A, it started as 4. I put it over 1. Any number we can put over 1. So I have 4 over 1. If I want the reciprocal, I need to take that and I need to just flip it. So the 4 is going to go into the bottom and the 1 is going to go into the top. So the reciprocal of 4 is 1 over 4. The reciprocal of 1 over 3 is 3 over 1. Or if you wanted to, you could reduce it to a 3. And the reciprocal of 3/4, once again, I'm flipping. I'm switching where the numerator and denominator are, is 4/3. And we're going to use that information in our lesson today. So lines intersect in 3 different ways. They intersect once, they never intersect, or they intersect everywhere. Okay, so that's what we've talked about before. But when they do intersect, there's 2 options for that. So if I have 2 lines that cross, sometimes they just make an X or something similar. But sometimes there's something special about them. They are perpendicular. So you might have seen that symbol before. It just means that I have a right angle. It means these 2 lines form a 90-degree angle, and that's something special. And we call those lines perpendicular, and their slopes form a relationship. Their slopes are opposite and reciprocal of each other. So that's why we did that warm-up. We practiced what an opposite was, we practiced what a reciprocal was. And so we're going to use that today. So here's my example. If my slope is 1 over 2, a perpendicular line would have a slope that would be negative 2. My slopes are opposite and reciprocal. The opposite of a positive is a negative. The reciprocal of 1 over 2 is 2. So here's another example. My slope originally was negative 2 over 3. But if I have something that's perpendicular to that line, it would have a slope of 3 over 2. So this was negative, now it's positive. It was 2/3, now it's 3/2. So we're going to get into some practice. So the first example, state the opposite and reciprocal for each slope. My slope is 4 over 1, now becomes negative 1 over 4. My slope is 1/3, it now becomes negative 3 or negative 3 over 1. And likewise with C and D that you can try on your own. And so now we're actually going to apply this. So it says state the slope that is perpendicular to the given linear function. So here's my original function, y equals 3x plus 1. I want just the slope, that's all I need right now, just the slope for a line that is perpendicular to this one. Well, first I got to identify the slope. My slope in my original is 3. So I'm going to take that 3 and now I'm going to do the opposite and reciprocal. So it was positive, it's now negative. It was 3, now it's 1 over 3. So I'm just identifying the slope that is perpendicular to the given line. Same thing on letter B. Now it says y equals negative x. Well, I could rewrite it as y equals negative 1x. So now I know my slope for my original equation is negative 1. So if I want a slope that's perpendicular, it's opposite and reciprocal. So opposite of negative 1 is positive 1, and the reciprocal of 1 is 1. And you can try letter C on your own, as well as D, E, and F. Our goal was to get to number 3, where we're writing an equation that is perpendicular to the given linear function. Now I have a note that answers vary. Right? What does matter is the slope is opposite and reciprocal. Your y value, your y-intercept can be almost anything. So if I start with y equals x plus 1, that is my original equation, my goal is to write an equation that is perpendicular to that. Well, my slope is 1, so I'm starting by writing my perpendicular slope, which would be -1. And then I just need to put it into my equation. So if I have a slope that's -1, I get y equals -x, or y equals -1x, and then I just need a y-intercept. +7, +2, -1, -0.5. It really could be anything. So let's go to letter C. My slope of my original line is -1/5 x plus 1. That's right. That's like my equation. My slope then is -1/5. I need my perpendicular slope first. Okay. So the opposite of a negative is a positive. The reciprocal of 1/5 is 5. So my perpendicular slope is 5. I just need to put that into an equation. Y equals 5x minus 3. Y equals 5x. Y equals 5x plus 1. There's an infinite amount of possible correct answers. You have to have y equals 5x in order to be right. What follows that x, as long as it's a constant, it doesn't matter. All right, so that's if I have something that's perpendicular. But what if I have something that's parallel? So lines that don't intersect are parallel. Their slopes are the exact same, but their y-intercepts are different. So when I say exact same, I mean the exact same. Slope is 1/2, a parallel slope is 1/2. The exact same number. So let's practice that. State the parallel slope for each equation. So my slope of the first one is 1, so my slope would be 1. My slope of the second equation is -3x. Parallel slope would be the exact same thing of -3. Same thing on this one. And then this one. The slope is the exact same number in the original equation. And example 5 says write an equation that is parallel to the given function. So once again, your answers are varied. There's an infinite amount of possible correct solutions. You need to make sure, though, that you do not list the exact same y-intercept that the original equation had. We want something that's parallel to it, not something that's the exact same. So the slope is the same, but the y-intercept is different. So y equals 2x. So my slope is 2. So in my new equation, something that's parallel, it has to have the same slope, but it has a different y-intercept. So this one has a y-intercept of 0. This one could have one of -1, or -2, or 12, or 13 halves. It doesn't matter as long as it's not 0. So letter D, y equals 1/2 x minus 7. My slope has to be 1/2. So y equals 1/2 x. And then as long as my y-intercept is not -7, it doesn't matter. I'll have a correct answer. Okay, so we talked about parallel and perpendicular. Now we're going to compare them. So it says determine if the lines given are parallel, perpendicular, or neither. Defend your answer. So if they're parallel, my slopes are the same, different y-intercepts. If they're perpendicular, my slopes are opposite and reciprocal. It doesn't matter if the y-intercepts are the same or not. And if it doesn't match any of those, then it's something else. It's just two lines that intersect. So in the first one, here's my two equations. You should identify the slope in each equation. So the top one has a slope of -1, the bottom one has a slope of 1. Those numbers are not the same, so they're not parallel. They are opposite and reciprocal. The opposite of negative is positive. The reciprocal of 1 is 1. So these are perpendicular lines because their slopes are opposite and reciprocals. If I look at letter B, I identify the slopes first. -1/5 and negative 5. They are not the same number, so they're not parallel. This is negative and this is negative. Well, they are not perpendicular. Now you may be thinking, Mr. Slover, they are reciprocals. 1/5 and 5 are reciprocals. Yes, I agree. But in order to be perpendicular, it has to be both in opposite and reciprocal slopes. You don't get to pick and choose which one you want. It has to be both. Okay, so that's why this one is an example of neither. Those two lines are just two lines that intersect. There's nothing really special about them. And then letter C, we got another example of perpendicular. So if we have parallel lines, our slopes are the same. Our y-intercepts are different. If we have perpendicular lines, our slopes are opposite and reciprocals. Doesn't matter what the y-intercepts are. They could be the same. And if we have slopes that don't match either of those two, then it's nothing. If you have any questions, make sure